Good morning, everyone. Today, we'd like to discuss the topic hydrolysis of salt.
So let's proceed to our lesson objectives. First is to define hydrolysis of salt. Second is to predict whether a salt solution will be acidic, basic, or neutral based on its parent acid and base. And lastly, to explain how hydrolysis affects the pH of a salt solution.
Hydrolysis of salt. It is a chemical process that occurs when a salt dissolves in water and its ions react with the water molecules to produce either an acidic or basic solution. The word hydrolysis comes from hydro, meaning water, and lysis, meaning breaking apart. So it literally means breaking apart by water. When a salt dissolves in water, it separates into its positive and negative ions. These ions can sometimes interact with the hydrogen ions or hydroxide ions from water, changing the balance of the solution.
So, what is hydroxide ions? A hydroxide ion is a negatively charged ion made up of one oxygen and one hydrogen bonded together. It forms when water loses a hydrogen ion, carries a negative charge, and increases the pH of a solution, making it basic or alkaline. It means having a pH greater than 7. It makes the solution basic because they increase the number of negatively charged ions that can neutralize hydrogen ions in water. Second is the hydrogen ion. It is a positively charged ion that forms when a hydrogen atom loses its one electron. It forms when hydrogen loses an electron and often combines with water to make a hydrogenium to make a called hydronium ion, which increases acidity and lowers its pH. Makes the solution acidic because they increase the number of positively charged protons in the water. So, let's proceed to the solutions, which are acidic, neutral, and basic. First is the neutral solution. A neutral salt is formed when a strong acid reacts with a strong base. This balance is due to an equal concentration of hydrogen ion and hydroxide ion. Pure water is a common example of a neutral solution. Ken?
An acidic solution is an acidic salt is formed when a strong acid reacts with a weak base. An acidic solution is a liquid that has higher concentration of hydrogen ions than pure water, resulting in a pH value below 7. For example, in NH4Cl from HCl, a strong acid, and NH3, a weak base.
So the third one is the basic solution. A basic salt formed when a weak acid reacts with a strong base. A basic solution, also known as alkaline solution. It is a liquid that has a higher concentration of hydroxide ions compared to hydrogen ions. This results in a pH value greater than 7. So this is an example which is CH3COONA. A CH3COONA is a weak acid that pairs with an NaOH, which is a strong base.
There are three types of strong acids, which is hydrochloric acid, nitric acid, and sulfuric acid. As you can see here in the screen, there are types of salt, which is 4 types of salt. A strong acid plus strong base plus strong acid plus weak base plus weak acid, strong base, and a weak acid plus weak base. These are types of salts. These are the 4 types of salt. So, how do we do hydrolysis of salts? As you can see here in our example, which is CH3COONA, our example is this topic is easily simple to understand. So, ang CH3, COOH, it is Na, it could be break down into two parts, which could turn into CH3, COOH, and NaOH. Why is it that ngano ang ana ang noun? Because when it comes to elements, bases, and ions, we give an ion to those na makulangan. So kapresan A, Na. Makulangan ang Na o oxygen and hydrogen. So gitagaan siya sa CH3COO. So as you can see here, atong CH3COOH, it is a weak base. Ang NaOH, it is a strong base. A strong base and or a strong acid. Saan na to pagkabalo na which is the acid and which is the base? We can base it off last element, which means or sa first element. Pero here unsa man ni siya nga unsa man ni siya nga element, unsa man ni nga acid, di ba? Kaingon man ko last time nga there are 3 types of strong acids. So here is NaOH, which means it is a nitric acid. Why nitric acid? Because if hydrochloric acid siya, meaning dapat ang NaOH kay naay carbon. Pero wala may carbon ang NaOH. So only thing nga naa ang NaOH is nitrogen, which is nitric acid. So magbase ra ta na. Now sa base, wala man siya acid, no. Ang mga basihan naman to is CH, ni carbon, hydrogen, oxygen, walay hydrochloric, walay sulfuric, wala say nitric acid. So that is a base. Now how can we determine unsa ang weak base o unsa ang strong base? Now in terms of strong, makabalo na ta kay impil naman ng NaOH or ang nitric acid sa 3 types of strong acid. Pero unsa na to pagkabalo kung weak ba or strong ang tong base? Magbase ta sa iyahang element. As you can see here, na ay carbon, oxygen, and hydrogen. Ang carbon, oxygen, and hydrogen, these are low elements nga naara sa mga first and second periods na radaraa. Dool-dool na siya nga elements ba nga makita nimo. Although, when it comes to sa ato ang strong base, nitrogen, lisod-lisod makita ng nitrogen, naroon na sa tunga. So, strong base dyan na siya. While ang ato ang weak base is dali ra makitaan. So, remember that a weak acid will always give rise to a conjugate. And a strong acid will always give rise to a conjugate. As you can see here sa right, ionization or dissociation, which is ang CH3COONA mahimog CH3COO negative plus Na positive. Giseparate lang nato siya. Pero without those extra elements ng kaparehas nga gi-separate sad pero wala tong extra elements nga naa ang kapare sa Na, wala na yung oxygen ug hydrogen, ang CH3COO, wala na yung hydrogen. So, yes, base ta na. Pero remember ang sa akong giingon. A weak acid will always give rise to a conjugate. So, if magbase ta sa tong pag-separate ganiha, ato ang base is weak, di ba? So, dapat ato ang based sa dissociation or ionization, dapat strong siya. So, opposite sa siya. If ang strong acid will always give less to a conjugate. So, pag NaOH, itong ganiya, strong base or strong acid, sa dissociation or ionization, mahimo siya weak acid. Now, let's move on. Switch lang na, no? So, ato ang, after you have done that, you can react a strong ion to the H2O. Remember, the only thing that reacts to an H2O is a strong ion. Now, as you can see here, our example, nanay, another solution sa, di ba? CH3COO negative plus H2O. Haman mi kakuha na. This is where makuha na mo ang pag ningon magdiri ganihan, the only thing that reacts on H2O is a strong ion. So ato ang goal here is to react an acid to a hydrogen. Ang hydrogen, it is a constant term nga mo react jud siya sa mga acids. Pero weak man ang atong acids, dili man siya strong. So magbase ta, dapat ato ang strong conjugate, atong strong base, dapat ang ato ang i-react sa hydrogen. So atong base man ang strong, which is the H3COO, kaya na dapat itong react sa hydrogen. So, negative man siya, CH3COO, negative plus H2O. Now, balik ta sa dissociation or ionization. Ma-turn siya into CH3COOH plus OH. Why? Nag-give ang H2O o another hydrogen sa CH3COO para makomplete iyang element. Now, yung OH na nabilin. After all, ang H2O kay na duha ka hydrogen. So naghatag siya isa ka hydrogen sa CH3COOH para ma-complete yung element. Ngano nag-negative naman ng OH, nag-switch na sila. Ang CH3COO negative nabutang sa OH. 'Di ba? Nagbutang iyang negative sa OH. Switch lang ni. So, sayo na kayo ni. 'Di ba? Para ma-understand pa niyo yung samot, na may pakita nga video. So, stay tuned. No? Makitaan sad na to sa last. Hala, unsa man ning acid? Is this basic? Is this neutral? Is this acidic? So, unsa na to? Pag no. Makabalutaan when it comes to the last term, which is OH. Now, what term unsa man ang term nga naay OH sa tulo ka buok nga ang basic nga acid. So, unsa man ni siyang acid? Basic, di ba? Okay, ang atong last term is OH. Ang mga, which is alkaline. Magbase ta sa iyang last term. So, ang only ga-accept sa acids nga OH is basic. So, nami pakita nga video, stay tuned. Good luck.
So ammonium chloride looks something like this, NH4Cl, right? Okay, so when we take ammonium chloride, where does it come from? Okay, so when we dissociate this guy, okay, so it will be NH4 plus Cl minus. Now, ladies and gents, you can either do this question in one of two ways, okay? It's either you take my videos and you remember this stuff, okay? Or you try to understand it. Either way, it works, okay? And you'll still be able to get full marks. So ammonium chloride. So we want to prove whether the resulting solution is acidic, basic, or will it remain the same. Okay, or will it remain neutral. Okay, so now we need to find out once again, where does ammonium come from? So it means here we reacted two things. We reacted NH3 ammonia with hydrochloric acid. Okay, so now remember what we said. So what type of so this definitely is an acid, this guy is a base or alkali, right? So in this case we're saying, all right, if we took NH3 ammonia, right, which is a base, right? So in this case, what type of a base is this? We know it's not sodium hydroxide, it's not potassium hydroxide or any of the hydroxide bases. So in this case, this guy is weak. So that's a weak base. Okay? And what do we know about hydrochloric acid? Remember we said we've got three strong acids, hydrochloric acid, as well as sulfuric acid, H2SO4, and nitric acid, HNO3. So definitely that guy is a strong acid. So that's a strong acid. Okay? So look at that. So we said a weak base rather, will give us a strong conjugate. So definitely this guy is strong. All right? And then we've got a strong acid there. It gives us a weak conjugate, isn't it? Okay, so we said you always take, now we're going to prove, is ammonium chloride, okay, going to be, when we put it in water, is it going to, the resulting solution, is it going to be acidic, basic, or will it remain the same? So all that we simply say, okay, look at this. I'm going to answer it before we actually do the resulting solution. So it's a weak base with a strong acid. Who's winning there? Definitely the acid is dominating, so it means the resulting solution will actually be acidic, but let's prove that now. Okay, now remember we said we take the strong conjugate and we react it with water. So I'm going to take NH4 plus, it's the one that's going to react with water, H2O, and what does it do? Okay, what do we get? We will get NH3. Please note there's no NH5 plus. Okay, so what will form is NH3. So what would have happened? It means this guy would have donated H plus, okay, to water. And so what would you have on the other side? That's H3O plus. Okay, so as a result, what do we notice? We've got H3O plus on the other side. So it would simply mean that the resulting solution is acidic, and we've proven that, right? Why? Because of the presence of our hydronium ions. Okay, right, so that is how you would prove that there. Okay, so I hope that has been helpful. That is how you actually do the hydrolysis of salts. Okay, and I hope that has been helpful. Okay, give us a thumbs up if you like this video, and I'll see you guys next time. And that's it for now. Sharp, sharp.